Hey everybody, today we're going to graph some lines and shade some stuff in. Before we do that, let's take a look at a story problem. Not much of a story, but just to kind of talk about inequalities. How do you compare two things? Especially if the situation's a little bit harder, like this one that we're going to do here. Let's see. Sorry. All right, so we've got John sells t-shirts, plain shirts are 5 and graphic shirts are 7. So in order to match his product costs, he has to make at least $1,200. So when you read this, you can see that we have 5 plain. So I'm just going to call this 5P. And is a plus. He's got graphic t-shirts that cost 7. So I'm just going to call this G. And then we have this $1,200. Well, if this was your money, and if you're comparing the money you're going to make, which is this side over here, here's the money you're going to make. This is what we're focused on. Which one would you want to have bigger? I'd want it to be more than $1,200. I'd want it to be as much as it could possibly be. Now, the fact that it says at least means that this is the smaller side. This side is the smaller side, but it could also be equal because it doesn't say more than. So at least means it could be the same, and that sometimes is confusing. But now that we have this inequality is just a statement that has a greater than, less than sign in it. We're going to be able to figure out the answer to part B. If he sells 150 plain shirts, so 5 times 150, and 7 graphic shirts, is this going to be $1,200? Is he going to be able to make the $1,200? So if we put this in the calculator, in fact, let me get rid of this so it's not confusing. This actually equals 1170, which, no, he didn't make $1,200. So no, he needs to sell more shirts. So if he sells 90 graphic shirts, what's the minimum number of plain shirts? So now we don't know plain shirts. So now we're going to have a variable that we're going to have to figure out. So $5 for a plain shirt. How many do we need? We don't know. Plus $7, and we've got 90 of these. We want that side to be greater than or equal to 1,200. So 5P, 7 times 90 is 630. And we're going to subtract that 630. You know, we add or subtract first, generally. So now we have 5P is greater than or equal to 570. And we can't have half a shirt, so if it works out to be a decimal, we'll have to round up. And so it works out to be a whole number, though, so we're good. 114. So he needs at least 114 plain shirts. He could sell 114, but it'd be nice if he sold more than that because he'd make more money. So that's basically how these inequalities are in terms of a story problem. The easiest way to sort of see the solutions, because there's an infinite amount of solutions, is to use a graph. So we're going to be graphing lines, which we can do. We've already done this, but then we're going to shade in some areas. So it says here, we're looking here in the middle. It says we're going to use, first of all, slope-intercept form. So we're going to find the y-intercept, and then we're going to count the squares with the slope. So we used a dashed line for these symbols, and we use a solid line, then there's a line under it. So it used to be an open and closed circle is now solid or dashed line. Now the shading, greater than, we shade above for greater than, above the line. And we'll go through this many times. And you shade below the line for less than or equal to. So that no line under it is a solid or dotted line. Line under it is a solid line. But I'll show you some and it makes a little bit more sense. So when we graph, this is where you start. As you know, we start here. This is your y-intercept. And this is your y-axis. So on the y-axis, we go to -1. Now the slope is the number next to the x. And the slope is y over x. Or rise over run, or up or down, and then over to the right. So from here, we're going to go up 2 over 3, Up to you how many times you want to do that. I'm good. Now we look at the symbol. The symbol has no line under it. So we're going to make a dotted line. And we want less than. So we want to go below the line. So think, well, where does y get smaller? Well, y gets smaller going this way. All right, so -3, -4, -5. It's getting smaller, smaller, smaller. So this is below the line. Now your shading doesn't have to be crazy. It doesn't have to be a different color. It just has to be noticeable that you know that it's over here. Let's try this again. Y is greater than or equal to 4x. Now there is no number out here. So no number means your y-intercept is 0. So we're going to start right at 0. And now our slope is -4. It's negative, so we're going to go down 4 rather, to the right one. If you want to do that again, you can. There is a line under the symbol, which means it's a solid line. And it's also greater than, so we're going to shade above the line. So when you look at your answer, it should be definitely a solid or a dotted line, and you should clearly know what area is colored in. Now, before you can graph a line, you have to solve for y, everyone's favorite thing. This is why we spend so much time doing this. It was not just a fun exercise, but it's something that we have to be able to do. So that means get the y to be the only letter on one side. So we're going to subtract the 5x. You can't actually subtract 5x. We're just moving the 5. So we have 12 minus 5x, and then divide by 3. You need to simplify this. You cannot leave it like this. It's very hard to graph. 12 divided by 3 is 4, and then we have -5/3. You can put the x on top. Now we're back to where we were on the front, and we're ready to graph. Start up 4. Because 4 is the plain number. On the y-intercept, that's your y-intercept is the 4. The slope is -5/3, so we're going to go down 5 to the right 3. Now you look at your symbol. Symbol is got a line under it, so it's a solid line. Symbol is less than, so we're going to shade below the line. Now something else that kind of works good is if you have a highlighter. Sometimes it's a little bit easier to shade. You don't have to use a highlighter. I'm trying to be fancy. Again, solve for y. So we're going to move this x over here. So you can think of it as moving it. You can think of it as subtracting it. It's basically the same thing. So now we're going to have -12 minus x. Now be very careful. We are dividing by a negative. And when you do that, you must flip this over. Now you do your division. So this is gone, so we get y. Negative divided by negative, so we have a +2, negative and a negative, and we have positive 1x over 6. So for this, again, you start at the plane 2. So we start up 2, because that's your y-intercept. This is your y-axis. The slope is 1 over 6, so we go up 1 over 6. 1 over 6, right? Up 1 over 6. Look at your symbol. I made it green. It's greater than, so no line under it. So dotted. And greater than means shade above the line. So we will shade above the line. All right. One more complicated one and then one easy one. Again, this belongs over here, so we're going to subtract it. So we have 9x over here and a minus 9x over here. So 12y is greater than or equal to -60 minus 9x. Divide by 12. We're dividing. It's not negative. Do not flip it. So y is greater than or equal to -5. And then we have to reduce this. It's a negative. 3 goes into both of them, so we have -3x over 4. 1, 2, 3, 4, 5. Now from there, we have negative 3/4. We're going to go down 3 to the right 4. If it goes off the grid and you don't like that, then switch it and go up 3 to the left 4. Same thing, it's just going the other way. Look at your symbol, line under it, solid. Look at your symbol again, greater than, so we shade above. Done. Now the shaded area, what this means is all of these are answers. Anything in the shaded area is the answer. A solid line means an answer is also on the line. A dotted line means the answers cannot be on the line. X is less than negative 4. Ooh. Y equals mx plus b. Well, we don't have a y. The x is not next to a number. We can't use this. So this is the other form that we're going to see these lines in. And when you do this, when you have this, x equals a number is a vertical line. I know it's not equal. So go to your x-axis and go to negative 4. And then think about, well, where else is x negative 4? I could graph the point negative 4, 2. Negative 4, negative 2. Negative 4, 5. So up and down, up and down. So this is the line where x equals negative 4. Now to make it less than, it's like a number line now. Where are all the numbers less than negative 4? They go that way. So that's how you graph that weird line. Now, of course, we're going to put this together. The story problem and the graph. I know you're excited. Now, the problem when you have a graph is you can't use A, B, C. You have to use X and Y. Otherwise, it's really, really hard to graph. So let's read what we have. We have Stephanie spending 10 cents per text and 25 cents per picture sent on her phone. Her monthly budget is $30. So she doesn't have $31. Well, she got $30, so we can't spend more than that. So I'm going to do this kind of in order. Text came first. So I'm going to say X equals text messages and Y equals pictures. You can't use T and P. How are you going to graph that? I mean, I guess you could use T and P, but it'd be harder to graph. I'm going to use X and Y. So we're going to do the money, 0.1X plus 25 cents, so 0.25Y. And then we have this $30. Well, $30 is the most we can spend, so $30 is the big side. Now she actually has $30, so we could spend $30. And now we need to graph this. And then, of course, you need to figure out what the scale would be. You have to label your axes and your scale and all that good stuff. So you can solve for y if you want to, which is how I'm going to do it. So we're going to have subtract the 0.1x. I ran out of space. I'll put it over here. 0.25y less than or equal to 30 minus 0.1x and divide by 0.25. This is actually not too bad. When you put this in the calculator, 30 divided by 0.25 is 120. And then 0.1 divided by 0.25. Make the calculator go to math, and then it'll say fraction right away. And just hit enter, enter. And we've done this many times in class, but that's how you take a decimal and make it into a fraction. And so we have negative 2/5 or minus 2/5 x. Remember, we really want that to be a fraction. So now we got to graph 120. I'm going to count by tens. I just think that might be good. So I'm not going to label all of them. Here's 10, 20, 40, 50, here's 60, here's 80, here's 100, here's 120, 140. Going up and down, Y was pictures. So this is the pictures. This is how many pics. Going left and right was text messages, if we look back here. So this is the number of text messages. And this is the number of pictures. It's important that we know what we're looking at when we look at the graph. I'm going to count by tens going the other way too, just because it seems like it'll work out pretty good. So there's 20, 40, 60, 80. I don't know how much I need. So we're going to graph this. So I'm going to go up to the 120, which I've already found. It's right there. And then my slope is negative 2/5. I'm going to go down 2, 1, 2, right 5. 1, 2, 3, 4, 5. Down 2, right 5. I'm going to draw the line. And then I'm going to think about, okay, less than. What that means is anything below the line works. So all of these answers below the line are possibilities for her to keep within her budget. So using your graph, give 2 possible combinations. So be careful. Those that like to live on the edge, I'm going to go ahead and pick a nice point right in the middle. How about right here? I'm not trying to live on the edge. I'm not trying to take this and make this difficult. I want to make this as easy as possible. So it looks like 20 texts and 80 pictures. A combination will stay within her budget. Yeah, you can pick right online if you want to. That's a real thing. Like we could pick this point right here. That's 100 texts. And looks like reading the graph is hard for me because I can't tell where this is. 80 pictures. I would strongly suggest that you pick a point that's clearly in the shaded area. You could even pick 0, 0 because she could send 0 texts and 0 picks and stay well within her $30, right? Because it wouldn't cost her a thing. Now, if you notice that graph is in the first quadrant, this is what we mean by constraints. It doesn't make any sense for x or y to be negative. So we could also add to this that x has to be greater than or equal to 0 and y has to be greater than or equal to 0. And that's what's going to keep it in the first quadrant. That was so fun. We're going to do it again. Scott's making $12 an hour babysitting and $8 an hour at the grocery store. He's going to need to make $600 to buy a computer. Again, $600 is the minimum. It'd be nice if he made more. So let's think through this. I'm going to do X is the babysitting, and I'm going to do Y is working at the store. So this is hours babysitting, and this is hours at the store. I don't know what my scale is yet because I don't know how big my numbers are. So if my numbers are real small, I'd be dumb to count by tens. Right? So let's take a look and see what we get for the equation. So we've got 12x, right? We're just reading it 12 per babysitting, 8 per store, so plus 8y. And then we have over here the 600. So it's okay if you get 600, but it'd really be nice if you got more than 600. So let's solve this thing. So we'll subtract the 12x again. I gotta graph this. So 8y is greater than or equal to 600 minus 12x. We'll divide by 8. So y is greater than or equal to 600 divided by 8 is 75. And 12 over 8, we got to reduce that to 3 over 2. 75. I'm going to count by 5s. You can count by 10s if you want to, but I'm going to count by 5. So 5, 10, 20, 30. Ooh, might have been a bad idea. Oh no. Ooh, it fits. All right, so 75 is right at the tippy top. I'm going to do the same thing going this way. 5, 10, I'm counting by 5s. 20, 30, 40, 50. All right. So now we can graph the line. So we're going to go up to 75. And then from there, we're going to go down 3 to the right 2. Down 3 to the right 2. I have a hard time drawing a straight line, so I'm just going to keep going. Now this only works because the scale is the same. If the scale was not the same, we couldn't do it this way. We'd have to figure it out. So if you want to use this counting method, you got to keep the scale the same. So again, we're dealing with less than this time. So less than would be in through here. And it doesn't make any sense that they're negative, so it doesn't go beyond the first quadrant. And so this says use your graph to find 2 possible combinations. So I'm going to pick I'm going to pick one that's right on a number. So I'm going to pick this one right here. This looks like 40 and 10. So 40 hours babysitting and 10 hours at the store. Or you could pick, like I said, you could pick one on the line because the line's allowed to be. So this could be like these two numbers right here. So 10 hours babysitting and 60 hours at the store. It makes more babysitting, so it makes more sense to work more babysitting. So there you have it. A bunch of lines that we're graphing. Be sure to dotted or solid. Be sure to shade in above or below the line.